Hi guys, so I wanted to go over a couple of problems from today's class worksheet and from the AP questions that you did on in this packet. So first from the worksheet, I want to go over number 10 and 12 just to show you how we can write them in simplest form. So if we look at number 10, we have, this is number 10, y equals e to the 4 ln of x. And so a lot of you may have looked at this and seen this as e to the something and use chain rule, which is fine. You'll get a correct answer. You'll get full credit for it. But sometimes it's important to notice some other math properties right away to make our task a lot easier. So if we look at this input, it's a log. And I know one of my properties of logs is this number in front here. I can rewrite that as ln of x to the 4th, right? One of our log properties. And then another property we may recognize is e to the ln. These are inverse functions. And so they end up dividing out to 1, and we drop the exponent. And so all we did was rewrite this original formula in simplest form. This is equal to this. And now to find the derivative, well, we just need power rule. Y equals 4x cubed. Done. So again, it's just a matter of recognizing some of our math properties. Then if we look at number 12, so number 12 we have y equals and some kind of radical. And since we're finding the derivative, we will write it in exponential form. So this whole thing is being raised to the 1/2. And so I see this as chain rule. I have something on the inside being raised to an exponent. And so by chain rule, I'll take the derivative of the inside. So in here I have 8x plus 4 times derivative of the outside, and so I bring my 1/2 in front by power rule, rewrite my input, and 1/2 minus 1 gives me negative 1/2. And again, if it's free response, you can leave it, but let's simplify. So I have 3 terms here. These 2 terms I can combine. This is raised to something, so I can't. So 1/2 of 8, we get 4x, 1/2 of 4 is 2. And since this is being raised to a negative exponent, I'll go ahead and drop it into the denominator. I'll rewrite it in radical form. And so here's our answer, but we can simplify this even more. If I look at this numerator, I can factor out a 2, and I'm left with x plus 1. And in my denominator, I can do the same under the radical. They each have a 4x in common, and I'm left with x plus 1. And since I have 4x times x plus 1, I can separate this as radical 4x times radical x minus 1, and this is a perfect square. So I can pull out that 4, it's a 2, and rewrite what's under my radical. And, oops, squishing it in here, rewrite my numerator. And so now these 2's are on the outside. 2 divided by 2 is just 1. And so my final answer in the most simplest form, there's my y prime. So it's important to try to practice simplifying, again, just in case there is a multiple choice question and the answer will be in simplest form. So now let's look at this AP packet, and I wanted to, I'm not going to do 27, a lot of you got it correct, but just to discuss, they give us this, so it looks like the first derivative, they already differentiated, however they didn't isolate dy over dx. So in order to find the second derivative, you should first isolate dy over dx. So just divide this guy over here. And then you would have to do low d high minus high d low over low low, your quotient rule. Again, implicitly, since there are y's here. And then once you have that second derivative, wherever you see a dy over dx, you should then plug in what dy over dx is, which is 2x minus y over x plus 2y. So after you find the second derivative, and you'll have dy over dx in the answer, plug this in, but do not simplify. Then just plug in 3 for every x, 0 for every y to get your answer. So a lot of work here, just tedious work, but not so bad. Number 28. So number 28, let's see. For t is greater or equal to 0, the position of a particle moving along the x-axis is given by, and they give us our position function. What is the acceleration of the particle at the point where the velocity is first equal to 0? All right, well, I know if I have position, we know how to get velocity. We just have to take the derivative of the position that equals my velocity. And so derivative of sine is cosine of t. And derivative of cosine is negative sine, so that becomes positive. And so we have our velocity. We know we're going to need our acceleration, so we may as well find acceleration, which is v prime of t. And so derivative of cosine, negative sine. Derivative of sine is positive cosine. So we have our two functions. All right, so again, we're looking for acceleration at the point where velocity is first equal to 0. So let's first set this guy equal to 0. So let's just, I have cosine of t plus sine of t equals 0. So bottom line, if I look at this, I pretty much want to know when these guys should be the same. Well, let's just put opposite, right? If I move this over, it's opposite. If I have 1 minus 1, I get 0. So we need these to be the same number but opposite signs. And we want to know when this first happens. So first of all, let's think, when is cosine equal to sine? Again, think about your special angles. 30, 45, 60, or better yet, let's think in terms of radian, pi over 6, pi over 4, pi over 3. You know at 45 degrees, which is pi over 4, cosine and sine are both radical 2 over 2. But we want to know when they're opposite signs. So I know in quadrant 1, where pi over 4, cosine and sine are both positive. So they're both positive radical 2 over 2. Oh, but quadrant 2, 3 pi over 4, that's when they're opposite signs. Cosine is negative here, so here I would have negative radical 2 over 2. Sine is positive, right? So positive radical 2 over 2. So, oh, this works. We're in quadrant 2. That's the first time that they're both opposite signs, and we want to know where they're equal. And that happens when the reference angle is pi over 4. So I know t equals 3 pi over 4. And so this is what I'll use, this is the point that I'll use to find my a of t. So now a of t, or actually a of 3 pi over 4 equals, well, if I have negative sine of 3 pi over 4 plus cosine of 3 pi over 4 equals, well, sine is positive in the second quadrant, so this negative stays, and this is radical 2 over 2. Cosine is negative, so we have negative radical 2 over 2. And so altogether I have negative 2 radical 2 over 2 My 2's divide out to 1, and I'm left with negative radical 2. One more I wanted to do. And that was number 18. So if we look at number 18, I'm looking for a limit as h approaches 0. And even though this all looks strange, right? This looks like look what this looks like. My f of x plus h minus f of x as h approaches 0. So if I did plug in 0 here, I would have ln of 4 minus ln of 4, which would be 0. Plug in 0 for h, up, indeterminate. So once I'm taking a limit at a number and it's indeterminate, I need to do something. Well, in this case, I don't know about doing any kind of algebra, so right away what comes to my mind is L'Hopital's rule. L'Hopital's rule. And so since it's indeterminate and it's a limit, I can use L'Hopital's rule. So if I take the derivative of this guy, right, it's derivative of the inside, which is just 1. I'm taking the derivative with respect to h, since there's all h's here. So derivative of the inside is just 1, and ln of something is 1 over something. Minus ln of 4, well, that's just a constant, so derivative of constant is 0. Over derivative of h, well, that's just 1. So I'm left with just this piece. Now I can go ahead and plug in 0. 1 over 4 plus 0, well, that's just 1 over 4. Okay, I hope this helps.